And so we're going to do things a little differently here this morning. We're basically going to do a do one together, practice one together type of a scenario. And so here we go. We're going to do this first one together. My advice to you is draw pictures when necessary or when helpful. I think that that'll often be the case, not always, but often be the case. And use the problem-solving strategies that we've talked about before. Know that these are going to involve quadratic equations in some form or another. So let's take a look at number one. It says a hall rug covers an area of 63 feet. You know, as I'm looking through here, I'm going to highlight that. Area of 63 feet. That's obviously some math, right? Area, numbers, 63 feet, or 63 square feet. Clearly some math. Find the dimensions of the rug. If it is 7 times longer than it is wide. So I feel personally that this is one where a picture could be helpful. We've got a hall rug, typically a rectangle. So I'm going to draw out a rectangle here. Do a little bit of labeling with our rectangle here in just a second. I know that the area is 63 feet, but I want to focus on that second sentence. It says, if it is 7 times longer than it is wide. It is 7 times longer than it is wide. And so that tells me that the length and the width are unknowns. So if we're going to be labeling our picture here with some dimensions like length and width, what would you suggest as far as that goes? Christiana?
I'd put x and x on the width and then 7x and 7x on the width.
Sure, yeah. Where did you come up with 7x? I get the x as an unknown, but yeah, 7 times longer. I totally agree with you. I think that's exactly right. Question?
Do you need 2 7x's and 2 x's?
No, you could definitely get by without this one or that one.
Because
I thought it would be 7x instead of y.
Well, okay. So if at all possible, we would like to keep the number of variables as low as possible, right? And so, Hunter, you said, I thought it would be x and y.
7x and then y.
Okay, so,
You'd be able to combine the x.
but there's only one x if you have a y.
Yeah, so like in this case, I say we could combine the x's, combine like terms, and then it'd be 8x if we put it in an equation.
Okay, you're getting way ahead of me. I haven't even talked about an equation yet. We will. We definitely will. I'm just talking simply about how do we label this thing.
Oh, okay.
You're jumping way ahead of me.
I get it.
I really don't understand why we would have a y there, where I've put a y.
Yeah.
Simply because, like I said before, I would like to keep this down to one variable if possible.
Okay.
So if one side, like, let me put it like this. If I said Hunter has 7 times more money in his pocket than Rocky does, sure, there you go. And Rocky has $5 in his pocket, wouldn't we just take the 5 that Rocky has times 7 to figure out what you have? So I wouldn't introduce like a new variable into that. I would just say whatever Rocky has times 7.
Okay.
Okay. So let's deal with area. This brings in a little bit of basic geometry. How do you find the area of a rectangle? Length times width, base times height, yeah. So this would be 7x, gentlemen, please pay attention. 7x times x is equal to 63. This is going to be that key equation that Hunter was starting to get around to, where we take the length times the width, and we are told that the area is 63. This equation is very important. This would be a key step, because without this, there's nothing to solve. There's nothing to figure out. Wants to know the dimensions, we've got to have this. So, what would be a suggestion from you guys as far as how to get going with the solving part?
Move 63 to the side.
Okay, so minus 63. What is 7x times x?
7x squared.
7x squared, actually. 7x plus x is 8x. 7x times x, 7x squared. So you guys' suggestion of subtracting the 63 over is good. If we're going to solve this, we need to recognize that it's a quadratic, right? Degree is 2. So in order to solve this, we're going to need to factor, just like we've been doing. The first question we ask ourselves is... So hey, I'm sorry. We need... Sorry, we need, yeah, GCF is right. But I need to go back a second. Rocky, you said,
No, I'm good.
you're good?
Where did the
Yes.
X go?
Christiana's suggestion is to factor out the GCF, which in this case is what? 7.
You're embarrassing.
Parentheses, x squared minus
There's a hole.
It's a 9.
9. Thank you.
Oh, 9.
Now, guys, there's a lot of details going on here.
Do next.
Jake and others, I am very afraid that you are missing all these details. Just too much random little chit-chat going on. Hope that you'll be mature enough to plug back in here. Did you guys notice that the leftover in the parentheses looks kind of special? What does that look like to you? Yeah, so 2 terms, it is the difference of squares. So this would factor as x minus 3, x plus 3. So now we have completely factored this, and that's time to use the zero factor property. This is where we set each factor equal to 0. The first thing I'm going to write should be a little alarming to you. I'm going to take each factor, with this 7 being the first one, and I'm going to set them all equal to 0.
That doesn't work though, so 7 is not equal to 0.
Yeah, Rocky, you are correct in saying that 7 does not equal 0. So what that means simply is that this does not give us any solutions. 7 doesn't equal 0. So the only things that might give us solutions would be the next 2. So as I add 3 to both sides, or subtract 3 from both sides, I get x equals 3, x equals negative 3. One of those answers, in the context of our hall rug,
3.
makes no sense.
Negative, you can't have a negative area.
Yeah, you can't have a negative length of a rug or a negative area, you know. It would really be about having a length of negative 21 or negative 3 that would be the issue. So I would say that x equals negative 3, based on the fact that we're looking at the dimensions of a rug, makes no sense. Keep listening, we're almost done. X equals 3 does make sense, but we're not done because it wanted the dimensions. If x equals 3, what are the dimensions of the rug?
21 and 3.
21 and 3, because we know this is 7x, this is x. So we could say 21 feet by 3 feet. That would be your dimensions right there. 21 feet by 3 feet.
Would that be your final answer?
It would, yeah, because it just, if you notice right here, I'll highlight it in yellow. It says find the dimensions of the rug. So dimensions of the rug would be like the length and the width.
This is so fun.
Does that make sense? Cool.
I feel like I normally circle my answers, but I circle the length and the width.
I would, yeah, I kind of circled it down in the lower left. I have 2 things circled, I guess. But yeah, the lower left would be your final answer. All right, so next, you've had a chance to kind of see that one done. Had a chance to see that one done. I want you guys to try number 2 with a partner. Okay? Question.
What is a triangular pennant solid?
Try it with a partner. I'll help fill in the blanks if you need me to. I'll show you a couple things about this. You've got a triangular pennant. A triangular pennant could be arranged in a lot of different ways, but I'll just draw it like this. Something like that. And we're told to work with this triangular pennant. For instance, it says the height of this triangular pennant is 5 inches greater than the length of the base. So that phrase right there, 5 inches greater than the length of the base, is pretty important. Goes on to talk a little bit about area, but the number one mistake that I saw as I was walking around was simply dealing with the phrase 5 inches greater than. So that actually didn't really have anything to do with geometry. It's more about algebra. So based on that phrase right there, I'm going to make my base length x because it's a complete unknown. But based on that, I do know that my height is 5 greater than that. So I would label my height 5 plus x. As I walked around, I noticed that there was a decent number of folks that had labeled the height with 5 times x. Now, it's really important that we understand what the phrase greater than means. The example I used over there with Avery, I'll just say it out loud here. we presupposed, hey, Avery is 5'4", I'm 5'9", so would it be fair to say that my height is 5 greater than Avery's height? Correct? My height is 5 inches greater than Avery's height. So if we knew that she was 5'4", would we take her height times 5 or plus 5?
Plus 5.
Plus 5. If we multiplied her height times 5, I'd be like 26 feet tall. Right? So practically speaking, that makes no sense. And so that's why we would label greater than as being 5 plus x, or you could say x plus 5. Same thing. Ladies and gentlemen, are we solid on that?
Yeah.
Okay. So then it does go on to talk about area. It says the area is 42 square inches. So the next big leap here is, do we know the area formula for a triangle? Hopefully we do. It is 1/2 times base times height is equal to area. We know that the area is 42, so I'm going to put equals 42, and now we're going to fill in what we do know here. 1/2 times x times, I'll flip the order on you, x plus 5. That's going to be a really key step. That's going to give us our quadratic equation that we can use to solve for the base and the height. At this point, all the geometry is more or less done. Do you have any questions on the little bit of geometry we had to use here? Okay, the next thing I would do is clear out that fraction. To do so, I'd multiply everything through by 2. If I do that, that gives me x, parentheses, x plus 5, is equal to 84. And this, I think, fellas, is where you're going to find that the prime thing is going to go away. And then I would distribute the x. So this will give us x squared plus 5x is equal to 84. And in order to solve this, we need this to be in that standard form. So what do I need to do?
You need a minus 84.
That's right. Get the 84 over
I have a question.
by subtraction. Go ahead, Rocky.
Why don't we multiply the 5 and just have to watch?
Why don't we multiply the 5 by what?
2. Because we multiplied everything else by 2. I don't multiply
Yeah, so
x and the x plus 5.
I'll erase this here in just a second. But if I were to multiply that 2 through, here's what it would look like. It would be 2 times 1/2 times x plus 5 equals 84, right? So the 2 times the 1/2, it's 2 over 1. These just cancel out immediately, right? It's 2 over 2. There is no more 2 to go anywhere else.
Why does why does 42 get multiplied by 2?
So we are multiplying the 2 times both sides, right? We're not allowed to multiply the 2 by
Oh, yeah.
just one side without multiplying the other side by 2 as well. All right, so now it comes down to factoring, and I think you'll find this does factor fairly well. We could do the little diamond thing and say our AC is negative 84, our B is 5. The numbers that multiply to be negative 84 and add to be 5 are? Yep, 12 times negative 7 works. It's supposed to be a negative 7 there. So we end up with x plus 12 times x minus 7 is equal to 0. The zero factor property tells us that we need to set each factor equal to 0. So I will do that. And finally we subtract the 12, we get that. We add the 7, we get that. Because we are talking about a triangular pennant, one of those answers makes absolutely no sense. You can't have a negative 12 base. And so the negative 12 makes no sense. 7 does. So the base length is how far? The base length is what? 7. The height is 12.
Mr. Anderson.
Did you guess that right off the start?
No.
No, he did
I
some
didn't-
bogus
I-
work and
I
then you got
actually
7.
I actually showed my work, and I got it completely right. So I did 5x plus x equals 42, and then
Yeah.
I did 5x plus x equals 6x equals 42,
Got it, yeah.
6x minus 42.
It's one of those things.
Ow.
Yeah, if it were a multiple choice, you'd be the luckiest man at that moment around. If they were free response, the work is going to be no do.
You're gonna be like,
So,
caught.
hey, I'll see you all tomorrow. We'll continue on with this. See you then.
You're gonna be called